Hello everyone, we are back with another system design. This is a very interesting problem. We'll be talking about Tinder matchmaking and also Bumble matchmaking, basically any dating site matchmaking. So we'll be focusing on that there are millions of users. How do we match? How do we recommend the people to the others? So this is our problem statement, and we have done some discussion already. Like we saw that what does Tinder say, that what things do they consider before recommending, and we did a bit of capacity estimation, so we can quickly go through it.
Okay, let's start with the capacity estimation. The biggest, I think, factor here is the number of users that Tinder has. And so we have gone through the online Wikipedia page, which says that Tinder has 75 million active monthly users.
Adding a very small point over here, a lot of people keep asking that how do we guess the exact number? You don't have to be exact or very, very specific. You should have a rough idea that, okay, 2 billion for huge systems, 200 million for, say, systems like Twitter and all, 75 million, even if you guess like 100 million, 200 million, it is fine. You should be close enough. Just don't guess in terms of billions. Have a rough idea that, how many users do big systems have and how many users do small systems have. And you can always Google as well during the interviews.
Yeah. Straight up ask the interviewer, how many users does this have, or should I Google it? Because it's not a product manager interview, it's an engineering interview. They'll be totally okay with you getting these numbers by Googling. One thing that you probably should remember, this is helpful, is numbers every programmer should know. Okay, this is a very popular GitHub page. You don't need to by heart this, but this is good for you to know, right? If you do a 1 MB read in a disk, it takes 20 milliseconds. For 1 MB from SSD, it takes 1 millisecond. So this can be helpful. Or if you're doing a memory 1 MB, then it takes 0.25 milliseconds. So those numbers are useful. Like Keerti mentioned, nobody cares whether you guess 2 billion also, because 2 billion, it won't happen. There aren't that many young people who are looking for someone on Tinder, but it's okay. You're an engineer. They'll be like 2 billion, haha, it's just 100 million, and the interview will continue. Okay. This is one area of concern because this tells us how many people you can potentially match with. So if I am in Mumbai and I'm matching with somebody in Mumbai in a 160 kilometer radius, this is 100 miles, then I care about how many people are active in my city. Keerti, any idea of the population of Mumbai? This is also a product question.
I guess 2 million, 10 million.
It's 20 million, which is, and amongst them, I think, like if Tinder is super active, then it will be 2 million, because there's no way it's more than this. But yeah, so in the largest city that you can get to, maybe NYC, you will have 2 million active users. Why is this number important? Because
because if you think about dating apps, you need to match with people who are around you, because the whole point is that you want to go on dates with those people. So geographical area is a very, very important factor when it comes to matching people, right? So essentially, when you need to be recommended, you need to be recommended among these 2 million people. You should get recommendations. You should not get recommendation of someone who is sitting in Bangalore when you are in Mumbai, right? So this is a very, very important point when it comes to dating apps.
Yeah. So you have, let's say, user 1, user 2, user 3, user 4, and so on. And so in this, we will have to find a match. So if this number is 2 million, it's going to take a long time, because we'll have to go through all the users, go through the filters, whether this person is somebody we are interested in matching, whether they are interested in matching with us, and then we'll have to give a response, which is going to take at least I would say 4 or 5 seconds, because to run through 10 raised to power 8 operations, it takes 1 second in a modern hardware computer. So if you do this per user, every user is going to take 1 second. That's a lot of latency.
Right, and if we go by brute force approach, like if you have to find a match for me, you will have to go through all the 2 million people, right?
Yeah.
So
Yeah, that's a lot. Keerti, any other approach that we can take which is brute force?
see, so
But simple, yeah.
one thing is that you're finding match for one person. Another thing that can be that you match people out of like suppose I have 2 million people in Mumbai. I have to match any two people, right? I have to pair any two people. So I can also say it like 2 million C2, which is basically 2 million square, which is basically 4 trillion. So that is huge. So there are two ways basically. You either match for every single of the 2 million people and then go through the 2 million ones, or you basically do 2 million C2. It is the same thing. But yeah, this essentially becomes 4 trillion matches.
Yeah. Yeah, if you want to pre-compute all this stuff, that's a lot. So 2 million C2, I don't know how we can write that down, but 2 million C2 is roughly
4 trillion.
4 trillion. Okay.
So roughly, I think everyone will agree that computing this real time out of 2 million people is definitely not possible. We will have to do some pre-computations. We'll have to divide people into probably some groups, filter out people, and then based on that make the decision. So let's get started with that discussion, I guess.
Yeah. In real time, this is impossible. If you are trying to pre-compute, Keerti, like you mentioned, it's a lot of matches. Also, one thing is users keep getting added to this list. Preferences change. So if you try to pre-compute everything and one user changes, you'll still have to do a lot of computations to figure out everybody's user list.
That's a very good point.
Yeah, I think at this point we know that we will have to do some smart stuff. So let's get to the smart stuff.
I guess we should also quickly mention that, when will we recommend someone? So it is not like suppose there are two people, A and B, right, who are on Tinder. Suppose, so when we join Tinder, initially we mention some things, right, that what are my preferences, like gender, age, geographical location and all of those, some basic things that I say, and we add some photos. So these are the first things that we do when we join Tinder, right? Secondly, so as I was saying, if there are two people, we should be recommending B to A or A to B when both of them fulfill the filters that we have added. It is not like A is fulfilling B's, but B is not fulfilling A, still we will recommend one of them. So both need to fulfill each other's filters before we recommend them.
Right. So if a person says, I want someone in the age group of 18 to 25, let's say, and another person says, I want someone in the age group of 27 to 30, right? Their individual ages might be different. It doesn't matter what their individual age is. These two people should never be asked to match with each other. Even if the second user who wants people from 27 to 30, let's say, this is quite often when you're looking for someone older than you, and there is somebody else who's looking for someone younger than them, they might be the same age, but they can't match because one of them is going to be, actually both of them are going to be upset, right?
And also here one very it completely made sense. One more very important point. So gender and age is a very straightforward filtering, right? Versus photos, description, like for example, someone likes beaches, someone likes mountains. Those are not primary filters. Like gender and age is something that you should definitely not be recommended if that is not your thing. Photos and description could be like your secondary level of filtering. That maybe we can recommend someone who likes mountains and you like beaches, but maybe you'll be in the lower priority, but still can be recommended. Versus gender, age, location should be an absolute filter that we will not recommend. Does that make sense?
Yeah, 100%. These are easy also to understand. Gender, age, location. These, I don't know how we are going to do it. Let's see how we can do this stuff. Okay, let's also just put all of this stuff with, I think, one of the things that happens with photos and description, and then you also have like how active is this user, then you have other stuff. So these are all like product filters, if you ask me. The product team keeps changing this. These are like, once they are set, they don't keep changing. This filter is fuzzy. This filter is straightforward. Yeah.
Correct. So when we say algorithm is changing, like Insta algo is changing, YouTube algo is changing, Bumble algo is changing, Tinder algo is changing, this second part is going to change versus the first filter is always going to remain constant.
I think let's try to just do the basic part, which is the
Gender, age, location.
gender, age, location. Yeah. Let's start with that. Let's try to see if we can match users just using this, and then we can use the
second
fuzzy
part.
parts. Yeah.
Just quickly mentioning it, so Gaurav has written active, right? Why is that important? You must have heard, like, suppose in a dating app, I keep swiping, but I don't get swipe back, then that is not a good user experience. So Tinder or Bumble doesn't want to recommend users who are not active. So being active is a very common advice that is given to people who are on dating apps, that you have to be active so that you get recommended more. So that is one of the factors, and it does make sense also, right?
Yep. I would say if you are looking at all of those fuzzy filters, there's a lot of stuff that Tinder and Bumble and these guys, they don't want to make it public also, because people try to game the system. There was some talk of an ELO while we were doing the research here. So
which is no longer prominent, by the way. But
yeah, this is the best place to get actual tech info on Tinder and Bumble. So, but I'm just noting down a list. Let's say all the males are here, and usually you'll see that the males and females are neatly categorized into two groups. There will also be smaller groups of other preferences, but I think the most common preference is male to female. So let's just take the simplest case, and you have people from different cities. So I'll just take that.
by the way, we know it can also be like male to male, female to female. We know that is also possible, but this is easily extendable, right? And instead of just saying that the person that I want to date is a male or female, you also store basically, am I male or female? So there will be basically two genders. One will be what is my gender, and one what is the gender of the person I am looking for. So basically two genders, but you get the point that we'll have basically people divided into groups or cohorts, that okay, this is the group from which I can recommend people. That is the whole point.
Yeah, just to make it like more precise, I'm just setting male to male and female to female also. That this is more complete. There will be more, but let's focus on this part. It's the most popular, common, largest sets. So they are the hardest to solve if you can do male to female. Right. Here, when a male user comes to our system, let's say they are from Bangalore, first thing we have to do is we have to go through this female list, find all the users who are in that location, close to that location by 160 kilometers. Then we have to find all the people who they are interested in, their age bracket. Then they have to find, so because we have broken it into one set of gender, we don't have to go through the gender here, right? And now we have to filter through this list. So it will be a brute force approach. This still won't work, right, Keerti?
So also, I guess it is important to discuss that how will we be storing these users, like firstly, right, because we have divided them into groups, and also like location. So I guess you must also be thinking, and everyone might be thinking, that when we have to match someone who is nearby, it is basically similar to matching, say, Swiggy riders or Uber drivers, right? So we know that quad trees and geohash will come into picture, right? So that is also one thing. If I think of how am I going to store these users, like we are saying that we are going to divide them into groups, but divide them into groups and store them how, right? And also nearby, like geographically also they have to be nearer. So how do we store them in a group?
Yeah, maybe look, we have 3 clear filters. Let's try to build an index on top of this filter. This is a good idea usually when you're storing things, because if you're, let's start with the API. I think Keerti, this is something that you tend to do and it works out really well. Let's say we get user recommendations, and in this API, just give me 1 second, sorry. In this API, we send the user who's asking for the recommendations, and we send their location, and we, the user actually has the gender also, but I'm just making it explicit. And the last thing that we said was age. Yeah. Let's just start with this so that it's easy. So it would be perfect if we hit our database and we did a select users or select star from users where age between
is between
yeah,
age plus
whatever.
age minus, basically, yeah, age
Yeah.
plus minus 10, yeah.
Low and high. Yeah, maybe they have given plus minus, maybe they can give it as a preference. Then
Yeah.
we also mentioned gender, right? And gender equal to G, and we have their age, location, and location. Okay, this part is hard. What do we mean location in X?
Right.
So tomorrow if a new city is built, then, or if I'm 20 kilometers from the center of Mumbai, then how do you take care of that? So location is a bit of a challenge.
Also, I have one question.
Yeah.
Like, since you talked about the API, so do you want to pass location, gender, age from the front end, or should we be actually getting that from the user ID itself on the back end?
I think we can get it from the user ID. If they change the location, then we should note it down. Anytime they make profile updates, we should note this down. And because we have their current location, maybe we can just fetch it in the backend from the DB and then do a star. Get me all the users who have this.
So for those who understand quad trees, I think location in X, like trying to visualize it would be easier, because basically think of it like you have numbered or indexed your quads, right? So you're basically trying to find a person who is in nearby quads, like that, or in a city.
Yeah.
So basically, in very simple terms, you have basically put an index on the cities, or basically, even if it is a huge city, like suppose Bangalore or Mumbai, you can divide it like Mumbai, you can divide it into Bandra and all Navi Mumbai, like that. Bangalore, you can divide it into east, west, south, like that. And you can add indexes. And then suppose, the search changes, the preferences change, that I don't want to search only Navi Mumbai or in Bandra, I want to search an entire Mumbai. Then you can search like in location, suppose for the index of Navi Mumbai as well as Bandra, right? So the search would be like that. Does that make sense?
Yeah, I think this will make it even more obvious. What you said, Keerti, is exactly what I'm just trying to draw out. You have 4 directions in any quad tree. You might be, so if you're here in the center, right? This is the center of Mumbai, or the center of Bangalore, center of New York. You can either go northwest or northeast or southeast or southwest. Now, the reason I'm saying that is not because, there can only be 4 directions, there can be infinite directions. But what we do in computer science is, because it's a 2D plane. So like in a 1D line, you can go left or right. In a 2D plane, we assume that you can go left, right, or a combination of up and down. So you get 4 combinations. Now, if Keerti says that, I need to go northeast, after that what? So if you want to break it into further smaller pieces, then we can. So we will split it into even smaller pieces, and just give me a second, sorry for this. Yeah. Now this large northeast will become a smaller northeast here. It will have its own northwest.
Basically, guys, this becomes a tree. So basically the bigger rectangle is the parent, and the 4 quads that you have made are the children. And you can keep dividing your quadrants into 4 small children.
Yeah.
Based on some factors, like based on the number of users. Like if, like in Bangalore, there will be too many people, so maybe you will keep dividing to a lesser radius, versus in a city, in a smaller city, like for example Bhopal, there will be lesser number of people who will be using Tinder comparatively. So maybe the radius that you want to keep of a quadrant is going to be bigger. The length of the quadrant is going to be bigger. So in that case, you are not going to keep dividing it into further. So based on various factors, you can decide at how, where do you want to stop dividing your quadrants further.
Yeah. Now, okay, one second. What you said is perfectly fine. With that, we can easily define an area. If you want to talk about this small rectangle, you can keep on making this rectangle smaller recursively. If you want to talk about this rectangle though, let's say this is 160 kilometers wide, then all you have to do is say, go northeast first, then go southeast, then go southwest. Okay. So to write it down, to describe it is really easy. Northeast, comma, southeast, comma, southwest. That's it. So you are describing a 2D plane using these directions, and in computers you are not going to have, northeast, southeast. You are going to do it in binary. So if you assign 1, 2, 3, 4 to each of these directions, you can, with a single number, describe a area. So this will be called a geohash.
Exactly.
Right. So if a person changes their location, their geohash changes. So that will be stored in the database. It will be updated in the database. So for every user, we'll have their geohash, their gender, and their age. Okay. Keerti, if you are now firing a query here, select star from users, then there's 3 parameters that we are using. We can run an index only on one. So even
how
if
are
we
we storing the users? Like, is it a SQL DB? Is it because the query that you have written looks like a SQL DB? But also let's discuss, like, it could also be a columnar database, right? So how is our query actually happening? So we are querying based on the columns, right?
Yeah.
That it is not based on that if user ID is this. So even though the query looks like, it is still going to be on table, but I think here it does make sense to use a columnar database, like for example Cassandra, because firstly Cassandra can, like, we can horizontally chart it also, we can scale it easily. Also our queries are column wise, right? So in columnar databases it is like Cassandra, we are still storing it in table, but internally in memory what happens is that the columns are stored together, so these queries can actually become much more efficient. And also here, because the genders and age are going to be sort of similar, you can also flatten them together, right? Like for example, instead of storing female, 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 you can just basically store that, okay, from this row to this row it's female, like this is the age. So columnar databases can really optimize all of this for us. So I think something like Cassandra would be a good fit. What do you think, Gaurav?
Yeah, I think Cassandra sounds good. The concept that you mentioned is really interesting. You mentioned female, all of them being put together, right? So, sorry, Keerti, yeah?
Go on. No, you go on, sorry.
Okay, no, so in Cassandra, you also have this option that you can shard databases according to one factor, partition them according to one factor, and then you can sort each shard according to one factor. So imagine you have a database where there is, which is sharded by, let's say, gender. So all females go to one, all males go to another. It's not the world's best shard key, but it's possible. And then you have all of the people of a particular, I mean, they are sorted by age. Yeah, gender, or you can sort it by geohash. So when a query comes here, this is free. This is order 1 because you just go to that shard. Then you find all the people in a particular geohash. That is a login thing. And between them, you do a age query. So that is order n. Now, there is one other way to optimize this. You can make it order n overall. And the way to do is to use a composite key. A composite key is you take multiple properties and club them together. So now what I can do is I can take age groups. Let's assume that this is simple. Actually, in reality, it's always going to be complex. People's age changes, right? And their location changes. But for now, let's just take, you have the age group. This is being used to partition your databases.
Actually, very interesting point that you mentioned that it is going to keep changing. Cassandra also uses consistent hashing, so redistribution will also be minimized because of consistent hashing. So another reason why we can use Cassandra.
Even DynamoDB, like these two are very close.
Yeah.
You're right, DynamoDB.
Yeah.
In fact, we'll just share a link with you in the description, guys. You can check this out. So let's say you have age group and then you have gender plus location. This is your sort key. So what's going to happen now is you are going to say you want all the people between 18 to 25 as your preference. So we are going to hit all those shards. Then we are going to, we have gender and location sorted. So each of those is going to take login time. We're going to quickly find all users you're interested in each age group. And then we are going to fetch the results. We'll aggregate it and we'll give it back. So this will be order login pretty fast. Only problem, of course, like Keerti mentioned, is updates are there, but they use consistent hashing in Cassandra and DynamoDB, and they are able to reduce the data migration whenever this happens.
Yeah.
Yes. Awesome. So this makes our query efficient. Any thing that we have missed? I think our the main part, which is gender, age, and location, this is something we have been able to manage. Let's also talk about things which we can't pre-compute very easily, like photos and description and activity. How would we manage this?
A very simple way to go about it would be to basically, when the user is uploading, obviously this is going to happen asynchronously. This is not going to happen real time, like during the match. But when the user uploads itself, the photo, the description, and based on how active the user is, we can add some tags and again put the users into basically groups or cohorts, right? Like when we saw the Tinder page, they basically say that if a photo basically has beach or mountains, they're going to recommend similar people, which is very interesting actually, right? So now we have a lot of AI models that based on this photo, like you generate some keywords, like for example, mountain, beach, festival, or basically Indian wear, Western wear, or things like that. And then based on those tags, you group people together.
Okay, we have this stuff, let's say, stored in this database, and now we would like to
okay, mentioning one more point. So the first level of filtering we have already done based on the age, gender, and location. Now that would generate a huge number of people, right? Like for example, again, this is a getter API. There's going to be pagination. There's going to be filtering. Filtering, we have already talked about it. Pagination, because when we say get recommendations, like there are say 2 million people. Out of that, say suppose at least 1 lakh people you would have filtered out, right, from this. Let's say, for example, now from that 1 lakh, now the second filtering could be your photos recommendation and all of that, and you could order, like, so you do basically level of filtering and level of recommendation, and also basically has the other person swiped right or left for you. That is also a very important factor, right? You would have to store that also.
Yeah, I think one thing that I missed here is if you have this stuff, you have all of your preferences set up with this where clause, but we haven't thought of the other person. So and so you have this thing that their preferences also have to be taken into consideration. So you have to be in their preferences. Okay. I think this is, if we do a join query every time, it will get us killed. So how about we try something different? Maybe we need to cache these results.
Cache?
No, one minute. Getting all possible for a user. Okay,
so basically here itself, if select all from users where age is this, but also you'll have to check that, so here there are two things, right? One is, let me just write it down. Give me 1 sec.
Each user's preferences have to be pulled out, which is
when we are passing user, like from this user we have gotten this users, right? So suppose we are calling it user age, user basically gender, and user location, right? And now when we do this query, the below query, there we can check that so basically in this itself there would be another column, right, that what is their preference. So
Yeah.
is this user age within that preference range or not?
Yeah.
Do I make sense?
Yeah, it would work. So if you add enough columns in the user table, I think that's good, because for one user you can tell whether.
So I think it would be helpful if we just make the table and write that these are the columns. I guess
Yes.
that would be
So
helpful.
let's note down what does one user look like first. Okay.
Yep.
So user has an age, they have gender, and they have location. They'll also have an ID, which is fine. Now they also have age pref.
Correct.
Uh,
Gender pref, location pref.
Yeah. And so age pref can be male or male and female. Gender pref, I'm sorry, age pref is a age range. It's not a single age.
Correct.
Gender pref
right.
is also a range, yeah. And location pref is also like some way to tell that I'm okay with anybody in this quad tree.
Correct. Right.
Okay. So their location pref is probably going to be like 100 kilometers or 50 kilometers or 20 kilometers. So,
Right.
Okay. And then when we are running this query, we can use these parameters of preferences to filter. So we have and u dot
User ID, basically.
yeah, is equal to this user gender. Okay, this is their the current user who's querying, their gender, and u dot age between user age contains. Right, I'm not writing perfect SQL here. I'm just making sure that things make overall sense. And location pref contains current location. Everything in caps is what we are passing into our SQL function. So when a user is looking for a match, they're finding people who are within their preferences, and those users should have this user in their preference. I think, yeah, this solves the problem though. We can now get recommendations for any user.
Correct.
Okay, using a single query. Yeah. There is one problem though, Keerti. It's not login anymore. It's order n only. We have to, even though we find all the users who we are interested in, we will still need to go through them and see whether they are also interested in us.
Right. So another question that I was having, that how do we store that who has swiped whom? How do we store that information? Because this is just user, right? So we also need to store that who has swiped whom, because we would want to recommend people who have swiped you first.
I think what also needs to happen is we are coming to a point where it's becoming impossible to do this in real time. We mentioned that we care about photos, we care about tags through description, activity, and now we are talking about user actions. So storing all of this in DB, I don't think in real time we'll be able to filter.
I do think that, pay for every user, they can basically generate 10 to 20 recommendations. I guess that is why there are plans, right? That you can pay and get these many recommendations. That is why in free, they basically pre-compute, say 10 to 20 recommendation, and they keep. That is something that we can keep in a separate DB, or we can even cache it for people who are very active, right?
Yeah.
So it does make sense to pre-compute this, and then in the end, okay, we have first, like from 2 million, we have suppose filtered down to 1 lakh people, then we'll be filtering down to 100 people. Then in the end, when we will have 10 people, we can basically cache that. And we don't have to compute it on the real time. We can keep it. And if you're a paid user only, then we'll recommend more people. Basically, from those 100, if we have recommended first 10, then only if you're a paid user, then we are going to keep the rest of the 90 recommendations as well. Does that make sense?
Yeah, that sounds very interesting. It could be that our job, let's see how much that will require in terms of memory. Keerti, you're saying that if a person is paying, you keep giving them new recommendations. If they haven't paid, then at the end of the, let's say 100 recommendations or 50 recommendations, you say, okay, that's enough for the day. Pay us more.
Yes.
Okay, so there are 10 million like paid users on Tinder, and the rest of the 65 million are like free users.
So let's see
So-
for 65 million first. So for
Yeah.
these 65 million, say suppose, let's say 100, right? That is like a max case that I'm taking. It would be 10 or 20, but taking a max case, okay, 100.
100 potentials.
Recommendations, yeah.
Yeah. So per user per day.
So
Okay.
thinking of it like suppose you're generating these 100 in a cron job at night. Doesn't sound
Yeah.
very good, but just saying, yeah.
Yeah, that is true. That's exactly how they do it. Why are you feeling shy? They do it. Okay, if we have 100 users, then who are being recommended, and Keerti, you're mentioning that if it happens in a cron job, even if you do that, right? So 100 into 65M is equal to, I think, 6.5
Billion.
billion recommendations.
This
This
is
needs to be
worldwide.
cached. Yeah,
This
worldwide.
is worldwide. So we can, like we are using
Shard this
CDN,
also.
right? Yeah.
Yeah,
So
yeah. So okay. How much is this in memory? These are just profile IDs, I think, or profiles, like entire profiles. This one object will be at most 1 KB. Like, there's no way it's more than a KB.
even less, yeah, because because of photo, it can take some more space, but you can get that from S3 also. Like, so maybe it is just literally basic description, name and all that, right?
Yeah, yeah. Actually, yeah, you can fetch that separately also, because why do you need to cache everything? You can fetch it separately and get those profiles.
Correct.
Also, we can shard this. So let's say this is 100 bytes into 6.5 billion, which is 650 gigabytes. Oh no. Yeah, 650 gigabytes. So this can be sharded. All the Indians are in one place. It's highly unlikely that they are the Indians are matching with the Americans, because then just the location only becomes ridiculous. Yeah. So this is
So India would be what, 20% of this, right? If we just think of it like that. That
Yeah,
I'm
like
saying more. Yeah.
20%. Yeah, I would say
Yeah.
20%. Yeah, max. So then that will be 13 GB. Oh no, sorry, 130 GB. Yeah, you can easily get this sorted in a single place.
Then it becomes very fast, right? Because if you can just generate this, like, then it becomes
Yeah.
very, very fast.
Yeah, and even for paid users, there won't be more than 650 recommendations. Like you have 10 million active users, 65 unpaid users. So not all of
100
them come every
recommendations,
day.
we've taken a lot. I don't think the people are swiping 100 times in a day. 65 million people. They've
Yeah.
definitely overestimated. Those 10
No,
million
no,
paid
you-
users, what they would take 1,000 recommendations, but I don't think they could that more.
I
than
don't
that.
think you have met enough guys. I think 100 is totally fine. You're going to hit that limit very soon, and then there's going to be a lot of payments. But yeah, 130. So maybe 130 GB is feasible. So Keerti, your recommendation of why not just cache everybody's recommendations? This will work. Okay. So what do we have now? We can pre-compute people's preferences. Okay. We are no longer going to do
Interesting.
this real time.
Initially, cash seemed very stupid. Now it seems like an obvious thing to do. Yeah.
Yeah. Wow. Maybe we should have seen that in capacity estimation. I totally missed it. But yeah. So let's try to cache for every user their profiles. It will happen in cron jobs, like you mentioned, sometime when users are not active. So let's say weekdays, office time is the perfect time to run this cron job, and weekends maybe then maybe like late night, maybe 4 a.m. in the morning. Why are we saying this time? Because the pressure on the system is low. It's a good time to use that available compute for computing recommendations.
Right.
Okay. Okay, I think this is a standard batch job then. Maybe we don't need to get into too much detail on how this works. There are design patterns for this. If you're interested, guys, you can look at MapReduce, which will help. Yeah. Okay, and then you have these batches being run through AI models, and those batches are filtered using these kind of queries. Once for one user, if you have computed all the recommendations, we put that in a cache. So there needs to be a way to actually take care of that. Okay. Yeah, now if a person asks for, match me with people, we go through their cache, we pull it to we get that on the UI, and the UI can maybe run some small filters and the job is done.
I would like to add one very small point over here, but that would actually save us a lot. That instead of caching, like we are definitely caching on like the backend side also, right? But here, like it is said, right, that the nearer you cache, the better it is. So you could also use like SQLite and cache, say, 10, 20 recommendations on the client side as well. And that is also something very interesting to do over here.
Yeah, maybe 100 also, because
100
it's just
is not a
100
big number. Yeah, exactly.
Yeah.
So you can actually cache on the client side as well. That as soon as someone opens Tinder, you actually just cache 100 profiles over there.
Also, yeah, exactly. Debouncing can also be done if you're like swiping right very quickly. You don't send so many requests to the server. Just one request is sent, and then you're doing this computation anyway once a day.
Correct.
So this part we have simplified a lot. I think we have looked into this. There's a lot of magic happening behind the scenes that we are not talking about, like how are photos converted to tags. Guys, if you haven't checked out how, okay, I don't think we have mentioned image processing. Yeah, but that's not part of the system design discussion. You can process images, and through AI models, you can categorize them. Okay. Similarly, descriptions also, you can use word parsers to look at a description and start giving it tags.
Correct. So, and we can use something like Elasticsearch, like ELK stack and all of that to make our life easier over here, and to see that how efficient is your search basically.
Yeah, you can search for maybe logs there. Okay, that's it. Then we have talked about Tinder matching. Just to summarize, initial problem that we had is either trying to pre-compute with everybody didn't work, trying to get things in real time in a brute force didn't work. Both brute force approaches didn't work. We then decided on what factors really matter to us, and we saw that part of them are fuzzy, part of them are concrete factors. We then tried to do matching on sets. In that, we realized that location is something which requires geo-hashing. We also then realized that it's not just whether we are interested, it's also that the other party needs to be interested. So for that, Keerti, you mentioned that we can extend the table, have all the features that are necessary in one table itself. But eventually, even that was not sufficient for us to get a real-time match, because we looked at both parties should not have right or left swiped each other, and with all of that, we realized that let's just do a batch query, store everything in a DB, in a cache, and when a user asks for recommendations, we can maybe fetch them on the client side and store them in the client itself. So yes, that's how we would suggest tackling this problem of Tinder matchmaking. I think it's pretty good. I think we went through quite a bit. Keerti, what do you think?
Yep. This was very interesting. I definitely feel so. And you guys can also let us know if we missed anything, or if you would like to add anything. It would be great. And if there are any other such concrete systems that you would like us to cover, please do let us know. These are very specific problems, right? Like it is not like we are designing the entire Tinder. We are not discussing entire Tinder system design over here. So if you have any suggestions, like, because this is a series, we are going to continue this, keep giving us your feedback, and we'll definitely incorporate that and add more systems to it.
Thanks, folks. Have a great day. See you. Bye-bye.